There we go. I assume I'm live at this point. Um, Hello, everybody. Thank you for coming to the session. My name is James Penny. I'm the CTO of Device Authority. I've been doing security for about 18 years now, my entire adult life, and excited to talk to you today a little bit about KeyScaler AI, what it really does, and some of the core sort of principles and premises behind it. I think I'm the last full session of today, so if you stay with us this long, I really appreciate it. Thank you very much. So I'm going to start off with a big sort of exclamation mark here, and that's your AI is at risk. And I think a number of the sessions have talked about this throughout the day, and really the idea behind this concept is that in order to trust the data that is really feeding a lot of these new AI and machine learning processes and things like that, a lot of businesses are now, I think, relying on to make meaningful business decisions and take actions. We need to create this explicit trust. I think it's been referenced in a number of sessions with that data set. And in order to do that, we need a good, strong trust relationship with the devices that are effectively collecting and sending that data up to these processes. So if we kind of look at the end-to-end cycle, so IoT is the lifeblood of machine learning, and the idea behind that is, I mean, it's where a lot of that data is generated, either through sensors, whatever it might be, that are deployed in lampposts or factories or cars. All of these things. These are sensors connected to some kind of device or machine that's generating that data, and then shifting it over from generate to collect. And the symbol here at stage 2 really could mean at the edge. It could mean in the cloud. It could mean some other on-premise co-located thing. But the data is generated, it's collected, where it's then effectively stored and fed in for the analysis. And the analysis then at that point is really taking a look at that data and producing, drawing conclusions about it, which in turn drive the next step, which are the action. So if I'm, running all this data through my machine learning process, output is X, and I'm going to do Y. And then as a very final step, as a visualize, it could be as simple as a report, could be something else. But in this end-to-end process, you could start to see whether the sort of genesis and the creation and the enablement of a lot of these AI processes is really in those IoT devices. And that only really works if the data is trusted, right? So how do we trust the data that's being collected and generated and uploaded? Because once that sort of pool of data is infected by malicious actors or whatever your threat surface looks like, it's going to poison the rest of those processes. So the collect will be collecting potentially incorrect data, or maybe it's the correct data but it's being replayed from yesterday or something. The analysis will be drawing bad conclusions. Your actions will be maybe the wrong things, and your visualization, depending on the attack, could either be we did something horribly wrong, why did we do that, or if the attack is sophisticated enough, you believe you did something right. So really what we've got is this sort of challenge for the AIoT delivery chain. So what that means is, and I did again hear it referenced, I believe, in David's session previous to mine and a few others, but is there's this implicit trust between the machine learning process and the data. The data sits, in a more protected zone. Typically, it's been collected, it's been uploaded to cloud, wherever it might sit, and it's sitting in this, like, within this trust boundary or corporate or enterprise trust boundary that's got a whole bunch of firewalls and safety precautions and things like that around it. And the machine learning process or the engineers looking at that might say, okay, well, that area is protected, so I know that data is good, which isn't necessarily the case because we need to sort of drive a more explicit trust with the things that are creating or collecting and generating and uploading that data for us. So why is there that trust problem? Well, I've sort of historically have outlined it as these three core issues. There are other problems, I'm sure, but there's these core points to consider is that devices are, when they're deployed on street lamps, when they're deployed in factories, when they're deployed in cars, vehicles, was referenced earlier, you don't actually need to have physical contact with vehicles, but they're exposed. And a large part of that is the fact that, maybe you don't have the same network security considerations or protections in place, firewalls, routers, and all this other bits and pieces that are used to protect like your corporate network and your corporate assets. But also, there's not the same level of physical protection. So, if I can walk along to a lamppost, pop the device off. I mean, it's mine now. I get to do whatever I really want with it within reason. And if it's a retail outfit, I can walk into the shop and the same that people are, stealing whatever it is that they're stealing, they could just pop a router or an edge device or a sensor or whatever it might be. And then they've got sort of access to that device and they can try as many things as they like. So exposure is a big problem. Now, exposure is a problem because the devices are potentially vulnerable. So 26,000 vulnerabilities reported in 2023 here means that, and not all 26,000 are going to be relevant to IoT devices. I get that, but that number is only going up. I don't think it's actually ever going to go down now year on year, but one can dream. But there are more zero-day threats than ever for a lot of these software stacks and devices. So when you look at server side instruments like platforms where you have only one port open and no physical access and all these other guards, then a lot of these can be mitigated. But where you're talking about a device that's public, physically public, it becomes more difficult. And a lot of the times they're unmonitored. I mean, the device comes in, it gets a whatever it needs to do, and maybe someone punches in a pin code for pairing it with something. You do with your Bluetooth all the time, and it's never really looked at again. It was probably somewhat guaranteed secure. I don't want to go that far, but for as long as the engineer that was there installing it, and as soon as they leave and walk out the door and get in their van, you have no eyes on it, you haven't seen it, unless you have some kind of process for really looking at it. There's no guarantee around what its real status is and what its trust relationship should be to the cloud services. So I'd look at these and I feel like authentication and authorization get put into two separate buckets, right? And they're two sort of, one I feel is a bit easier to do than the other one. And I'll explain why. So authentication is not the same as authorization. I'm sure everyone knows that. But authentication is the process of who you are. It's your proof of identity, whether it be X509 certificate shown here, dynamic device key generation, which is our technology. That there is an authentication process that really proves who you are. And that's the only question it's answering. Do you match the thing that you're claiming to be? And authorization is very much a wider, more contextual question. What are you allowed to do? And what parameters do I have to, encapsulate in that processing to try and figure out whether you're allowed to be doing what you're really asking to do? And, historically, I think it's been quite static, an authorization thing, and what I'll call static processing. But yeah, it's just about determining your permissions, and you can only do that once you've done authentication. So authentication is a yes, no, you are who you say you are. Authorization can get a little bit more muddy and needs a bit more context. And I think about these, maybe because I'm English, as go into like an event, like a private event at a bar, and authentication is the process of your name's on the list, you're showing your ID to get into the building, and there's what I'll call a static process again for validating your identity, and it becomes, does the face match the face on the ID? Is the ID from a trusted authority? Does the name match the name on the list? That's your authentication. So that by that point you're in. Yes, you're on the list. Get in. You're in. You're through the door. As you buy drinks throughout the night, you're going through a continuous authorization process. Actually, every time you try and buy a drink, the bartender, who has a good history of, hopefully, of spotting people who should buy drinks and people who shouldn't buy drinks, are doing an authorization check. That's what they're doing. They've been trained, much like machine learning. They've been trained to spot patterns and recognize patterns of people who should be buying drinks and what it looks like when someone shouldn't be buying a drink. That is a continuous authorization process in that context, and that's really what we need to strive and get to, for these devices that are generating all these data, that's feeding the analysis, that's driving business and maybe some other security outcomes. So how can AI really help with that process? If we, again, take a look at the differences in the buckets here that I'm just going to talk about. So again, I've put authentication in more of a static processing angle, and that, again, it's, you can write a defined routine to really identify or do identification and authentication for a lot of things, especially devices. But where you need the more advanced context, almost common sense, if you like, of should that device be doing that thing, that's really tough to do in more advanced use cases, especially at IoT scale. So, 1,000 devices, 100,000 devices, million devices, a blanket policy might do it, but realistically, I think in use cases, at least the ones that I've worked on, that's not really going to happen. So I really think machine learning and the inference process of machine learning is the only logical solution for driving validation and ensuring trust with our devices that we're deploying and that are feeding all of these processes. So, like I said, back to the kind of bar scenario, greater ability to perform pattern recognition, and reduce the burden of complex policy definition. So if you, again, take the bar scenario, there is a static processing angle that you could apply to people buying drinks. You could breathalyze every single one at the bar, see what their blood alcohol content is, and then decide whether to give them a drink. That could be a static process. The problem is it's got a great hindrance to people. You probably wouldn't get any patrons. And realistically, the bartender is able to do that job, but it comes down to what you'll call like common sense and that pattern recognition and that training that particular person has had. So realistically, we need to do that for machines and our security authorization systems. So what we've built is a number of different things that I'll just talk about in this particular slide. So KeyScaler still remains. So KeyScaler, the core platform, suitable there for orchestrating kind of scalable device onboarding, establishing device trust, orchestrating all the certificate signing, the device quarantining, the revoking credentials, all of the things that it usually and always has done at IoT scale is still there. But what we've added is something that we call the adaptive policy service. And the adaptive policy service is a way for, or a framework for extending KeyScaler to integrate and communicate with third-party services and additional authorization platforms like KeyScaler AI. So it's inherent in the platform. Doesn't really need anything else deploying, and it allows you to build your own connectors, just like a lot of things that we've done in the past. If you're familiar with the platform, we can and you can rapidly build service connectors to new CAs, to new IoT platforms, to allow and integrate the KeyScaler process and its certificate orchestration and delivery with these third-party services. But this extends that framework to allow us to call on additional services for the purposes of authorization, continued validation, to establish that greater level of trust with those devices. So what it does through the adaptive policy service and what you've defined in the policies within that adaptive policy service is to reach out to KeyScaler AI as a out of the box integration. And KeyScaler AI is an additional service. It manages basically the whole sort of machine learning pipeline, and it uses a lot of data that it basically processes at a tenant level, so it still supports multi-tenancy, to basically learn certain characteristics about the system. And one of those I'll talk about in more detail about anomalous device detection. But it also provides the sort of core inference, so the processing of that data to determine whether a device is good or bad, or whether we should not trust it anymore. And also supports things like model retraining in the instance that you need to introduce a new device model to the platform. It can also, in addition to that, and based on how you build out your policy definitions within the adaptive policy service, incorporate information from third-party services and third-party connectors. And again, we will build some, partners will build some, and you can also build your own. So this really allows you to take what KeyScaler AI does and augment it with your own data to say, yeah, okay, KeyScaler AI says that device is good, but maybe there's an SBOM integration, which I do believe we actually have as part of the KeyScaler service too, that says you're running the wrong software version. You're not running the same version that was shipped with your device, and you're not running the expected version of that software. So actually, while you are a legitimate device, your software stack is not good. And those things will come together and are provided through that adaptive policy service, or the APS, which is natively part of KeyScaler. So let's talk a bit about what a policy is. And I've got some examples here, really, of back to the original question of like how AI can help me sort of scale the security. Policy effectively, or a policy chain, or a policy document, or policy definition, whatever you want to call it, is essentially a set of rules. And there's normally more than one, but this is just an example. But you have a set of rules, and each rule typically has conditions and actions. And really how that breaks down is just the conditions are, what am I trying to match for which to apply this rule? And when I match those conditions, what am I going to do? I mean, it's fairly basic stuff. But if we take a look at how AI can help us enforce these, but also help us configure these at that scale, we'll take a look at what I'll call a static anomalous device rule. So what I've done here is taken a function or typical feature of KeyScaler AI, and I've tried to present it in a way that's, yes, I could probably define this statically, but you'll see how this doesn't scale. So we'll start off with a real simple one. I could create a rule that says if a device registers and it's not running Ubuntu OS, because all of my IoT devices run Ubuntu, so I shouldn't expect anything other than Ubuntu to come and connect. If a device registers and it's not running Ubuntu, then I'm going to alert the administrators, quarantine the device, revoke the certificate. Now, obviously, the actions you choose, completely up to you, as we've seen in things like healthcare and sort of 24/7 manufacturing. Immediately taking a device out of action the moment you suspect something might be wrong. Not always the right response. Sometimes you just want to alert, and that's really up to you. But in this example, if a device registers, it's not running Ubuntu, alert the administrators, quarantine the device, revoke the certificate. Get it out of action. It's not supposed to be there, which is great and works fine until you realize that there's probably a lot of hacker devices that are also running Ubuntu. I doubt that hackers, for example, or bad actors, or whoever they might be, are exclusively saying, no, I don't want to touch Ubuntu, I use anything but. So let's create a bigger policy definition. If my device registers and it's not all, the wording is quite particular here, but not all of the following. Ubuntu. Okay, so Ubuntu's still there. ARM V8 CPU. And that could be manufacturer, model number 2. It's got 4 gigs of RAM, let's say. 16 gigabyte drive. An Intel network card. Same version, same model, same firmware. You can see how for one device type, or one model, or one of my use cases, whatever it might be, this starts to become unmanageable. If I want the kind of strictest level of security for what I'm doing and checking for anomalous devices, right? So building up that picture is really tough, but managing it is also really tough. Now I could use device groups, sure, but I'd still have to do, 20 different device groups, and I'd still have to define 20 different devices, and it might change depending on who the vendor is for my particular project. So it does become unmanageable. So if my device registers and it doesn't meet all of these criteria that I've laid out in the static definition, then surprise, surprise, I'm going to let the administrators quarantine the device, revoke the certificate. Now, wouldn't it be great if we had a system that could learn what a known good device looks like so that our policy definition could get away from being 20, 30, 40 different declarations of all my device types and just says if a device registers that doesn't look like my other devices. And again, that's again, it's sort of equivalent to asking a human a little bit. That's how you would interact with a human, because that's what you would be trained to look at. And a human is pretty good pattern recognition, and they can look at a device and pretty quickly say, yes, no, it's good, it's bad, it's whatever it is. But from a static processing perspective, the idea, and maybe this appeals to you, I don't know, but the idea of defining 20 different device types and what they should all look like to avoid to stop a bad actor from trying to register to my system is not really something I'd want to do. This also drives the idea that we're securing or further securing the weakest part of the of any security system, any security chain, which is registration. It's always the case. Some methods and processes for registering and then subsequent authentication can be stronger, can be better. But regardless of how you look at it, registration is always going to be that weakest part. So bolstering that with machine learning to look at what a good device looks like and learn that and call it out when we don't see that is one of the core initial principles of KeyScaler AI and what it sets out to achieve. So let's look at another one. And this is something that's coming up. So I won't talk too much about it. I don't want to give too much away, but I want to talk about another one that looks simple on the face of it, but can actually become really complex. And that's hours of operation, right? So your device in your corporate environment gets deployed. It's there to do something. What I could statically define its hours of operation. Okay, if a device authenticates outside of 9 a.m. to 5 p.m., what am I going to do? What should I do? The someone's only supposed to be logged in between 9 and 5, and maybe you're incredibly strict and you say no one works before 9 and no one works after 5. But typically what you want to do is some leeway. So what I'll do is I'll extend it to 6 or 7 or 8 or whatever it is. But the difficulty is that while that may work for humans to a certain degree, IoT is not quite that straightforward, especially when you have a platform catering such a sort of diverse and wide range of different devices. If you're in retail, for example, the ovens probably shouldn't be firing at 2 o'clock in the morning. Which, by the way, could be a different 2 o'clock in the morning on the East Coast compared to what it is, in Europe or the other side of the planet. So you got time zones to also account for this. But if fridges probably do want to be running 24/7. Maybe they do have a check-in policy every evening. Maybe they're uploading. Maybe they need to get a credential or a certificate or a token that allows it to go talk to its connected platform, and it syncs a bunch of maintenance records, whatever it might be, for the day. Maybe it does that at 2 o'clock in the morning. So it's not quite that simple. So now my blanket policy is not really working. So I have to divvy these things up into different devices or different groups. So now I'm going to say if device 1 authenticates outside of 9 a.m. to 5 p.m., then, alert the administrators. If device 2 authenticates outside of 5 p.m. to 1 a.m., alert the administrators. Those aren't the work times. Those aren't the usual times that they should be calling or trying to do anything. So that's what I want to enforce. And if device 3 authenticates outside of 1 a.m. to 9 a.m., alert the administrators. So again, that doesn't really scale, because if you think about, again, different time zones, different store types, different vendor types, different things, and the different way that things work, wouldn't it be easier if I didn't have to design this grotesque policy definition and just call upon an inference sort of esque question? If a device authenticates outside of its own normal operational hours, if I could teach my system what good looks like for all of my devices, regardless of what they do, regardless of how they differ from each other, what does good look like for that particular device? So now your fridge wakes up at 2 o'clock in the morning every night, tries to sync records, but all of a sudden it's coming online at 10 a.m., 11 a.m., whatever it is, because a bad actor, someone's walked in the shop, someone's hacked into it, is trying to do something, someone's got physical access to that device because it's vulnerable and exposed. I look at that and I say, the fridge really shouldn't be authenticating. It's a weird sentence to say now, I say it back. The fridge shouldn't be authenticating at 10 o'clock in the morning. Its usual time is 2 a.m. and that's what I expect. And it came in at 2 o'clock last night. Why on earth is it coming in at 10 o'clock this morning? It's not usual behavior. So what we want to do is take away the complexity of that longer, I guess, policy definition and the excruciatingly boring process of looking up all the operational times for different devices, which you might not have to hand. You have to ask the manufacturer. And boil it down to, let's just learn what this device does and learn what's good for it, what is known good for that device, and apply a set of actions if it's outside of that. And you could look at, hey, all my fridges, could back it up with that. I've got data on 200 different fridges. They all come in at 2 a.m. I can't see a single instance of why a fridge would wake up at 10 o'clock in the morning and start trying to send data, start trying to get a certificate, get a crypto key to go and unlock something. So it's that learning that I think really drives a lot of the security value at IoT scale that's going to be impossible to manage. I mean, David and Khalil just talked about in the last session. The people. There's a lot of people, but there's more devices. There's not enough people to manage all of those devices and necessarily keep an eye on all of these systems. So this is like having your own dedicated person kind of watching these devices and looking out for that bad behavior. So what does the flow look like? Because I kind of talked about the components and the adaptive policy service within KeyScaler. So I got not a terrifically detailed diagram. If you want more information, please do feel free to reach out. Happy to have a conversation with anyone about it to a certain level. I get an NDA first. But we have a device effectively requesting authorization. Now, the authorization could come in different forms. It's really anything that it wants to do. If it's trying to register, if it's trying to get a certificate, if it's trying to get a token to go and connect to a service or get a crypto key, get a check for updates, whatever it might be, the device is coming, it's requesting authorization. The adaptive policy service is going to look it up and say, hey, I need to check whether I've seen this kind of device before. This device is, let's say, registering for the first time. I've got a policy here that says that all my devices that register have to be validated by the KeyScaler AI service to make sure that the hardware profile for that particular device matches what all of my other devices look like, to a certain degree. And you can see an example of this here. This is just sort of an example of sort of the clustering process that it goes through. But in that process, we're taking a lot of things into consideration. So for anomalous device detection in this instance, we leverage a lot of the data that and information that DDKG provides. So dynamic device key generation, DDKG, is our patented technology that allows you to register and onboard and establish trust for devices. And what it does as part of that service is really collect a lot of data about that device and attributes about that device. So I'm looking at, I mentioned it earlier, but the CPU manufacturer, the CPU model, serial numbers, firmware for your disks, your NIC, what your NIC looks like, who manufactured your NIC, your MAC address sort of format, because a lot of vendors of NICs have sort of an identifiable format for all of the devices that they produce. And it takes all of that information, and you're effectively checking against your registration control records that allow you to establish that initial trust. Now, I can go and check that. I can pass that information to KeyScaler AI and say, hey, does the information provided here look like all of my other devices? And you could get down to someone's managed to really create a very good replica of these devices, but the serial number looks a bit off, or the CPU is a virtual CPU because someone's running this as a VM, or it's actually a Raspberry Pi masquerading itself as your device. And the depth of that really comes from when we work with customers about dialing up or dialing down their security, and you get out of it what you really put into it. But in this instance, the device was good. It matched it looks like all of the other devices. And we're going to report back that that's okay. So the next thing we have to do is we have to issue the identity. We're going to get the certificate signing request signed by the identity provider, and we're going to provision the device. In this example, Microsoft Azure, create a new entry for that device, let the device go and connect to that service, and effectively do its job. And we can continue this process, effectively when the devices come to subsequently authenticate and get sort of a continuous validation process running throughout the device's lifecycle. So I'm sure you guys are pretty good at pattern recognition too, and you're going to see how this diagram goes. But here we've got a device, again, requesting authorization. It's a fridge waking up at 10 o'clock in the morning. Anyway, we're going to effectively, there's a rogue device that's coming. It's got enough information about the system. Could be an internal employee, I don't know. But it's a rogue device, and it's attempting to register, and it's communicating with KeyScaler, and KeyScaler said, well, actually, we need to check this against all of this other devices that have already registered. And we hand it off to that process. KeyScaler AI will check it. And in this particular example, I'm hoping you can see that from here, but there's an outlier. It's outside of the cluster. It's a bad device. There was something in it that didn't put it within its normal range. It's deviated from that baseline. So we're going to come back, and you can do this synchronously or asynchronously, by the way. And we're going to come back and say, actually, KeyScaler, that's not a good device. You should consider taking whatever actions are in your policy to deal with, a positive result from an anomalous device check. Positive being the fact that it was true, not false. And revoke that identity with the identity provider, disable that particular device in Microsoft Azure, in Azure IoT, or whatever you might be using, and alert administrators and do all of that the usual stuff that KeyScaler's been doing for a lot of people already. So you can see how that kind of plugs in, and how it all comes together. If you imagine, again, just that authorization really can be sort of any part of the system. We could also, like I said, inject or integrate with other third-party vendors and get data from other parts of the system. Maybe your anomalous device check is good, but you maybe only do that one on registration, but I don't know, let's say your software stack for some reason is different. You could also inject an SBOM validation. You could also check for vulnerabilities. If you have a third-party system that is scanning your application software for vulnerabilities and has come up with some, 7.5, 8, whatever it might be, 10, depending on what your own internal threshold is for scores. But there's a new vulnerability in that particular library that's on these devices, and we need to inject that as part of this overall authorization process. And maybe we do that check every time it authenticates, or maybe every time it tries to authorize and get access to something. And maybe we only do the anomalous device detection every so often. So it's really about how you create that policy, what it means for you. But hopefully a system like this really allows you to get the benefits of deploying at scale without needing to deploy all the humans at the same scale to watch and manage it all, and just kind of let it sort of overwatch for you. So for KeyScaler AI sort of features and benefits, and like I said, if you have if you want to reach out and talk about any part of this or your use case or how you might leverage this within your devices and your system, or if there's another machine learning or security problem that could be helped with machine learning, I'm always looking for input on things and ways in which we can expand. And please do reach out. We're happy to have that conversation. But like I said, so we have this ability to really detect these bad devices registering that are not like any other existing registered devices that you've already seen, or maybe you have seen and you've already quarantined them. And that really enhances that initial security, that initial registration, that weakest link in the end-to-end security chain. We do support retrainable models. So I did mention that earlier, touched on that. But if you have additional devices or a model, okay, we have to be careful by using the word model now. But if you have a device hardware model change, you can update the machine learning model to learn what a new good device actually looks like. So that's always handy with device revisions or introducing new devices to particular use cases. Again, retail seems like the one that has the biggest sort of mix and match in my head of different devices, but you could probably argue the case for automotive and medical too in a lot of senses. And it gives a better trust relationship with the devices, especially during that weakest link part of the entire process. So where you have maybe limited initial device identifying details. So what that means is I talked about the registration control records, and the more you put into a registration control record, the smaller your attack surface is really for that registration process. You can time bound it for a couple of minutes, a couple of hours, whatever it might be, geofence it, set the MAC address, set the serial number, set any other device ID, set the operating system, set things like that. But not everyone has access to all of that information so easily. So and if you think about scenarios where you maybe are in sort of slightly more edge environments, maybe you want to allow a certain level of autonomy in certain use cases for devices to register and be checked by this. So you maybe register a couple initially with some and make sure that those are known good devices, and that sets the benchmark for anything that can really register with the system in the future. In the outside of you getting a lot of manufacturing details about your devices or strong uniquely keyed or anything like that as part of the manufacturing process. And like I said, so it's a whole authorization service connector framework. So the adaptive policy service doesn't have to be limited to just KeyScaler AI. It's suitable for a lot of people to really just build your own sort of webhook style endpoints into for you to do your own authorizations with your own data sets, or call out to any other system and have additional checks, or even just maybe build another notification system for whatever you want to do. But that framework really allows that sort of flexible integration for either visibility or communication with those third parties. So with that, I'll say thank you ever so much for attending. As I said, I think the last full session of the day, and I appreciate everyone who's made it this far. There are a few questions, and I'll start at the top. So can KeyScaler AI help to make meeting the requirements of SBOM easier? Yeah, I think that's a good question. I think the whole, I think you probably asked that before I started talking about the SBOM bits, but the alluded to the ability to kind of integrate with third-party systems. So I think as a policy engine and a policy service in itself, the ability to really get to integrate these third-party checks, and there is one, I think, for KeyScaler itself, for you to store your SBOMs and have them validated with all of your devices. Through that adaptive policy service really makes that possible. And if, SBOM is quite a funny word. It's become another one of those sort of buzzwords that people have to include in a lot of presentations. But if there are other repos, services, things like that, that you want to validate against, because there are so many of them, then you're free to build your own integration, your own connector that could inject into as part of that process. I will say there are some things that we're doing. I don't know how much I can really talk about it, to learn about devices, software stacks, and compare when a device is going through this process. So it's really about if I got 100,000 cars connected, and in theory they should all be very tightly controlled software stacks, right? And the devices all kind of looks the same. So my hardware profile is always going to catch out anything that's not an official sort of TCU or whatever it might be, or part of that car. Your software stacks will pretty much look the same as well. And if I suddenly connect one day and my as part of my authentication or authorization process, my software stack says I'm all of a sudden running OpenSSL 1.1, when all of my fellow devices of the same type are running OpenSSL 3.0, then that is a process for KeyScaler AI and machine learning. But I won't say more than that on that. Is KeyScaler AI fully agnostic? I'd assume you mean, I would assume you mean device agnostic. To a certain degree, yes. Right now, as part of the core focus of what we did in terms of anomalous device detection, as I talked about, it's kind of predicated on collecting a lot of that information from that device, the serial number of the CPU manufacturer, the NIC, the firmware version, all the rest of this other stuff, and comparing it with what we know is known good and what's already registered to the system. So for that process to work, you do need DDKG. There is, again, right now, the next iteration will have a lot of agnostic features for devices that maybe are too small to sort of participate in those kind of DDKGS features. And you think more RTOS and things like that. Despite having DDKG versions for RTOS, there's a lot of checkboxes that people have around. I have to use certificates in my day-to-day operations, and we want to give them the full benefit of a lot of the stuff too. So it is definitely coming. Is there such a thing as too much AI? Is the last question that I've got. It seems like every technology company has a new AI product now. Yeah, that's true. Again, it's one of those buzzwords, and that's a funny question. Let me be very diplomatic as I answer it. I think there's a lot of people doing a lot of good things with AI. I think there's a lot of people doing a lot of very good things and solving a lot of good problems, especially in the security realm. So again, you've got this horrible situation where you have all of these tens of thousands, hundreds of thousands, millions of devices, and you can't possibly keep an eye on them. the closest thing you can do without AI, again, is going back to the static policy definitions, where all of a sudden I've got this policy definition that accounts for 200 different device types, with 200 different operating schedules and 200 different hardware profiles that I want to check against. And then I also want to check all the software. So now I have to detail the stacks of the software stack that's on that particular device. So I think there's a lot of really good things that are being done and useful implementations of AI. As with any, I think, new technology, and with the rise of companies like OpenAI, ChatGPT, and Midjourney, and all of these generative AI, I think it's obviously clearly very popular to jump on that sort of bandwagon. But some people are doing it for more legitimate reasons than others. I would say beware of, I guess, social media influencers that try and sell you scripts wrapped around ChatGPT. That's maybe what I'll say. Yeah, I think maybe there's too much AI sometimes. But I think for our space and for IoT, it's got a lot of legitimate plays in just to achieve the scale that we really need to achieve. Okay. So I think that was all the questions. So I appreciate, again, everyone staying to the end of the day and listening to me. If there's anything else that we can help with, please do reach out. We can also, I will say, KeyScaler as a service does also have KeyScaler AI capabilities available at this point. So if that is something that interests you, but you don't feel like installing any of your own software, then please do reach out through the website. You can find me on LinkedIn. I'm not difficult to find despite being in security. Obviously. So my name's James Penny, and I really appreciate you listening. Thank you very much, and hope you enjoy the rest of your day and enjoy day 2. Thank you.